Alright guys, we're going to start Chapter 8, and this is the first section of Chapter 8, which is functions. Okay, here are your key concepts. Go ahead and get these copied into your notes and replay me when you're ready for an explanation. Okay, our first key concept is an independent variable. Now, an independent variable means that values do not depend on another variable. So we can think of maybe the time. We've got seconds, minutes, hours. None of that depends on anything else. It's always going to be constant. That's an independent variable. Next, we've got dependent variable. And dependent variable depends on the input value. So let's say maybe the amount of gas that you need in your car depends on how far you're going to go. So that's a dependent variable. Functions are relations in which each element of the domain is paired with exactly one element of the range. And so domain, remember, we know as the x values, and the range we remember as those y values. Also, we have something known as a vertical line test. And a vertical line test is used to determine whether a relation is the function. And when you're using the vertical line test, you're only allowed to touch the vertical line once in order to be a function. Okay, so if you look here at this little picture I have on the screen, I've got a pencil and it's got arrows moving across the graph. So if you were to take this pencil and imagine that pencil going across your screen, or if you want to put your pencil up to the screen and move it across your screen, does all of those dots or that graph only touch your pencil once? And so if that is, then that means it's a function. But if your graph were to look like, let's see, here's an XY axis, and my graph were to look like something like this. And I took a vertical line here, and do you see how it crosses the vertical line twice? That fails the vertical line test. And then finally we have our last key concept of function notation, and this is a function that is written as an equation, can also be written in function notation, and it's just this f parentheses x parentheses, and we read that as f of x. So whenever you see this function, that just means f of x. Okay, so this is an idea, which means you need to get this example copied into your notes, and as soon as you get it copied, replay me. Alright, so this one is saying determine whether each relation is a function and explain. Okay, so if we go back to our first slide, it tells us that in order to be a function, the domain does not need to repeat with another range. So basically what that means is you cannot have your x values repeat. Your y values can repeat all day long, but your x values are not allowed to repeat. So let's look here at our example here. We have 54 as an x value, 56, 55, 54, and 56. Okay, so now we've got, let's see, 54 and 54, and we also have 56 and 56. Okay, so both of those are repeating 54 and 54 and 56 and 56 because your x values repeat. This is not a function. Excuse my handwriting, but I'm on my stylus. And the reason why is because 54 and 56 have two range values. Okay. Alright, you try this one as best you can and replay me when you're ready for the answer. Okay, so if we look here at our function, we've got the function 5, 1, 6, 3, 7, 5, and 8, 0. So we want to just pay attention to your x values, 5, 6, 7, and 8. Do any of those x values repeat? No, so this is a function. Yes, because each element or each domain is paired with exactly one range. And that's important because that's the definition of a function. One domain per one range. All right, you try this one as best you can. Replay me when you're ready for your explanation. Okay, so now we're still seeing if this is a function or not. And this is a little bit different than before because we had ordered pairs before, and now we're just seeing it in a table. So let's look at this couple right here. That would be the same thing as saying like 1, 7. So it would be familiar like the one before. This would be like saying 6, 6, and so on. Okay, so it's the same thing, we're just seeing it in a table format. Alright, so now we're trying to figure out if this is a function or not. So we're still going to be looking at the x's. We want to make sure that our x's never repeat. Well, uh-oh, look at this. I see a 1 here and a 1 here. Okay, so now my x's are repeating, so that automatically says that this is not a function. So no, 1 is paired with 2 range values, 7 and 8. Alright, now we're going to determine if the graph is a function. And when we do that, we do what's called the vertical line test. And so we have a vertical line, and you can sketch this graph on your paper as best you can. Try and be as accurate as possible. And I want you to take your pen or pencil, and I want you to run across that graph with the pencil nice and slow and see if any of these dots are going to hit your pencil at the exact same time when it's in the vertical position. In this case, in this graph, none of these dots are going to hit the pencil at the exact same time. So that means that this is a function because it passes the vertical line test. And that means that no more than 1 point on the graph for every x value. Alright, here is a you do. Go ahead and try this as best you can. Sketch out the graph in your notes and then tell me if it is a function or not. Okay, so if we take our vertical line test and we look here, do you see right here that this point and this point are on the same line? Well, what about this point and this point when I do a vertical line, and also here at this point and this point? So this problem right here, this graph, is not a function. It fails that vertical line test. So we're going to say no, does not pass the vertical line test. Okay, so it does not pass the vertical line test, therefore it is not a function. Alright, now we're going to talk about functions and equations. So this first example says if f of x equals 4x minus 7, find the function value. So let me take you back real quick. If we talk about f of x, okay, f of x written like this is the same thing as saying y. F of x equals is the same thing as saying y equals is the same thing as saying 0 equals. Now we're introducing what a function is, so we're going to read this as f of x equals 4x minus 7. So then when they ask you to find the function value, we're going to plug in this f of 5 into my function f of x. So I'm going to rewrite f of x equals 4x minus 7, and I want to replace f of 5. So everywhere you see an x, you're going to replace a 5. So this is going to be 4 times 5 minus 7. That makes that 20 minus 7, f of 5. And so f of 5 equals 13. Same thing for f of negative 6. We're going to have f of x, that same function, equals 4x minus 7. We're going to try and find f of negative 6. And to do that, we're going to plug in negative 6 everywhere I see an x. So it's kind of like when you had to check all those solutions, it's basically the same process. 4 times negative 6 is negative 24 minus 7, and f of negative 6 is negative 31. Alright, here's a you do. I want you to try these as best you can, and then replay me when you're ready for your answer. Don't cheat, and watch me do it. You try first, and then replay me. Okay, so I'm going to try and find f of 4 for f of x equals 14 plus 3x. So I'm going to replace this x with a 4 and say 14 plus 3 times 4. And this is f of 4 equals 14 plus 12. And f of 4 is 26. And finally, for f of x equals 14 plus 3x, I'm looking for f of negative 7. So 14 plus 3 times negative 7. And f of negative 7 is 14 minus 21. Remember your PEMDAS. And f of negative 7 is 14 minus 21 is negative 7. Okay, so we can also talk about functions describing the relationship between two quantities. For example, we could talk about the distance in a car traveled depends on how long you're in the car. So distance is a function of time, or d of t. So we'll look here at this example. Mariah spent $22.50 downloading songs to her digital music player from an online music store for 90 cents each. Identify the independent and dependent variables, then write a function to represent the total cost of any number of songs. So first, we know that the total cost is going to depend on the number of songs purchased. So the total cost, we can label as C, is the dependent variable, and the number of songs purchased, we'll call S, is the independent variable. So we'll say total cost equals the cost per song times the number of songs. So our function we're going to write is going to be the cost per song. The cost of the song is, we know, is 90 cents per song. So the second part of the question asks, use the function to determine the number of songs that Mariah has downloaded. Well, if we know the cost, we'll plug that into our function. 22.50 equals 0.9s. We divide by 0.9. And we get our songs to be 25 songs. Okay, I want you to do this one as best you can and replay me when you're ready for the answer. Now, I really want you to try this one before you replay me, so don't replay me until you've tried it. Okay, so a whale-watching boat travels at a speed of 5.5 miles per hour. We're going to identify the independent and dependent variables. Then we're going to write a function to represent the total distance traveled in any number of hours spent whale watching. So we're going to find the independent and dependent variables. So since the total distance depends on the number of hours, the total distance we'll call d is the dependent variable. So our dependent is the total distance traveled. And our independent is the number of hours. We'll call this T for time, and up here our total distance traveled, we'll call that D. So we're going to write a function to represent the total distance traveled in any number of hours spent whale watching. So our function that we're going to write is d of t is 5.5 t. 5.5 miles, 5.5 miles per hour times the time, number of hours. And then it asks us to use the function to find how long it took to travel 25 miles, rounding to the nearest tenth. So we know the distance traveled is 25, so we'll say 25 equals 5.5 t, divide by 5.5, and the time is 4.5 hours. And here is your extra practice problems. Go ahead and try these and have them for class the next time we see each other. Good luck.